Hi, this is Margo. This is Sunday evening, October the 24th, 2021. I hope everyone is safe and doing as well as possible. I'd like to welcome everyone to the show tonight. This will be my weekly update that I'll be putting on YouTube. We're going to be going over methane, sea ice for the Arctic and the Antarctic. We'll look at latest things that are going on at Palma, and we'll look at earthquakes and some climate data, and that'll be our show for tonight. So also, if you'd like updates during the week, I do that on my Subscribestar channel, and I do updates every day except for I take usually Tuesdays and Thursdays off, but I do updates, and I post updates every day, but I do videos those other days too. So that's on my Subscribestar channel, and the link is in the description box below, and we'd love to have you over there. So you're just going to have to bear with my voice. I got toxified a few days ago, and now also the weather has changed, and it's raining here. I'm in the Reno, Nevada area. I'll show you real quick. There's I guess y'all have heard about this big atmospheric river coming in on the west coast. But we're just on the edge of we're not getting a lot of rain yet. I don't know how much we're going to get. The mountains are going to get snow. Northern California is getting dumped on, and anyway, but I'm okay and haven't had any problems here. We've just had gentle rain since last night, or it started sometime today, I think. But winter has hit early, so you're just going to have to bear with my voice. I'm going to be clearing my voice a lot. So we're going to start with the methane data from NOAA. Now, in my show last week, I showed where the METOP-2 satellite, or METOP-A satellite, they're not using that data anymore. They're retiring that satellite, and that is out of the EU. Someone left a comment under my show last week saying maybe I could use data from the EU. Well, this is from the EU, and it's processed through NOAA, and so and CAMS is from the EU, and these are the only places that use satellite data, and the other places are just like you go out and hold a flask up. So this is, it is what it is. If you have a link to other methane data, you can sure leave it in the comments, and I'm happy to look at it, but no one has done that. So anyway, I thought about it, and so I thought, well, we still have the data from the METOP-1, aka METOP-B satellite, and so I've revived or redesigned my spreadsheet, and I'll show you in a minute, but I have a couple of separate pages where I'm just tracking the METOP-1 data by itself, so we can see the trends, and it goes all the way back to March the 1st of 2019. So we do have long-term data that I can show you from here on out too. So that was my big project this week, and So here we are. This is the 477/469 millibar reading. That's the level that I track for. This is for Saturday the 23rd, and for the morning. The mean or average was 1931 parts per billion. The high reading was 2451. And this low reading, look at this, 1318. Normally it's not that low. Normally it's around 14 or 1500. So we've even got a lower range there. We're still having a lot of pinks show up around the Antarctic coastline, so here in the southern hemisphere. So this pink range is a range between 2000 and whatever this high reading is, the top number. So that's a range, and we've got a lot of pinks all over the planet. In the afternoon, the mean was 1933, and the high reading was 2444. So here's the spreadsheet, and I'll show you what I did. So I've got 4 pages now. These first 2 pages are the old data with the 2 satellites, with the 2 readings for the 2 satellites for each day. So each day we had 4 readings, and then averaged them out. So here's where we were last week, where it spiked up, and we don't know if that was a glitch or what, but if it's a spike, it's a spike. So anyway, now here's the page for weekly chart for the Met-Op1, and then I have another page for daily data Met-Op1. And so I went through and changed all these formulas where I took out the data for the Met-Op2 and just left the data for the Met-Op1, and then divided by 2 all the way up. And so we have long-term data here for Met-Op1. So here for the 23rd, it averages out to be 1932 parts per billion. Now also what I did, since we did have Met-Op1 data for the 16th, which would have been the weekly data for the show from last week, I redid that, and so it averaged out to be 1929 last week, which was a decrease of 4 parts per billion for this satellite. And then here for the 23rd, it averages out to be 1932, so that's an increase of 3 parts per billion this week. Now generally the Met-Op1 satellite would run about 10 to 13 parts per billion higher than the Met-Op2. Not always, but generally that was the case, and I think they covered different parts of the planet. So this is what we've got. But see all these formulas. I redid every single one of these formulas. So it's all the way back to March the 1st of 2019. And so back then for the Met-Op1, the high we started out at 1869.5 parts per billion. That seems low, doesn't it, considering where we've been? And see, all of our highs are the same dates as before, and our lows are on the same dates. There is just a different number here. So far this year, we peaked out so far October the 2nd at 1936 parts per billion, which is this little peak here, and then it's gone down, but now it's coming back up. So I don't know if we've if that was our peak for this year or not. But see, the trends are the same. You can see it's just exactly the same with the peaks and the valleys, and it's just the numbers are a little bit higher. So we're 18 parts per billion higher than we were a year ago, and since March the 1st of 2019 we've gone up 62.5 parts per billion, and we're that much higher. And where our peak was on the 2nd, that was 66.5 parts per billion higher than March the 1st of 2019. So here's what happened this week. Here we were last week on the 16th. See, the 14th was the last day where we had the 2 satellites with data, and so it was on the MET-OP2 where it spiked up, and so the MET-OP1 data didn't spike up, so that's totally different. Let's see. So I just used that data. So here we were from the 16th, it was at 1929. That was last Saturday. And then Sunday it went up 4 parts per billion. That's a pretty good spike. And then Monday it went down 2.5. Tuesday it went down 2. Wednesday, here it starts going back up 1.5. Thursday it went up 1 part per billion. Friday it went up 0.5. And Saturday it went up 0.5. That gives us an overall increase this week of 3 parts per billion, and we're 18 parts per billion higher than a year ago. And I started tracking the data on a daily basis last year, back in February of 2020, because I just wanted to see how much change there was on a daily basis. And so here on the 15th is where I really started on a daily basis, and so from February 15th of 2020 I can see exactly what the methane was, and see all of these just have the MET-OP1 data. Look at this, where it went up 7 parts per billion in 1 week. That's, in 1 day. Yeah, okay, it went up 2 in 1 week. 7 in 1 day. That's crazy. Oh, I know what that was. Where it went down 8.5 in 1 day. I'm thinking there was a lot of white area on it, so it might have been kind of incomplete data. But I just take the data that they put out, and that's what we do. So there's that. So we're still in no man's land, and we're still higher than we've ever been at this time of year. So we don't know what to expect. You know, I would like to know if that was really a blowout on the METOP2 satellite. It just seems kind of coincidental that they decided to not report anymore the day after. So, you know, it is what it is. Now, we'll look at the CAMS data. This is from Copernicus Atmosphere Monitoring Services. They're out of the EU. There's the top of the website. Here's methane. I have Saturday the 23rd ready, Arctic view, and surface level ready to go. There's our color ledger at the bottom. So here the data is for Saturday, and the forecast period is Sunday through Wednesday. Now we're seeing solid green, at least the darker green and even lighter colors of green moving across the Arctic. This is methane coming up through the sea ice. It's still coming up here at Komsomolets. This has been almost 2 years that it's been billowing in that dark color. We don't know how high it is. It's just somewhere in this range here between 2160 and 10,000 parts per billion. It's popping off at Iceland again. Right there, see? Here's our problem spot in the North Atlantic still. And when you see the Arctic covered with these green colors, that's a sign of really high methane readings. So even though it's gone down a little bit, but it's gone back up, to see the green covering the Arctic, it's high. And the dark green is 1800 parts per billion, and then it goes up 20 parts per billion with each shade going lighter. Now this whole Scandinavian area has come back to life, and see this wave moving out, and Russia, and it's raining. It's raining at Norway. They've got a huge atmospheric river coming onto Norway there. And see, these background colors are light green and into the yellows even. And Koktovik is still high reading. The interior of Alaska is coming back to life. And Canada, this is just south of the Hudson Bay. Okay, now we'll go to the North Pole view. We can see the whole northern hemisphere from this view. We've got India filling up, and see it spilling over into the Bengal Bay, really high readings. Also China's filling up and spilling out over into the Pacific Ocean. These are signs of very high readings. Also see these waves moving out It's like the Earth is just opening up with the waves of the methane. We still have very high readings in Europe here. Germany coming down into Italy and then going east. The UK, here's Spain and Portugal. Here's the Persian Gulf. Now see, it's high around the Persian Gulf. It's a little bit lower in the water area there. And then here in North America, see this whole eastern seaboard. Look at this wave move out. See, this is signs of when you see waves like that, that's high methane. Look at that. You saw that fill up, just one big black blob there on this eastern side of the country. That's on, look at that, that's on Sunday. And Florida's, they're all filled up. Here's California. These waves. See the waves? So most of the northern hemisphere has at least the green as a background color, even over a lot of the ocean, but pretty much over all the lands, almost all the lands. Now we'll look at the Antarctic. I've started including this in my weekly show and my midweek show on Wednesday. This is South America, the southern tip. Here's the western peninsula of the Antarctic. Down here is the Ross Sea and the Ross Ice Shelf. Up here is, this area is the Weddell Sea. Here's the Weddell Ice Shelf, where you see the lighter blue color, or kind of blue-green, kind of aqua. That's methane coming up by the Brunt ice sheet. It's also popping up periodically here at the Larsen B ice sheet. Let's see. Watch here. You'll see it pop up. See, it filled in there. This area on the east, where this little V shape where it comes in, that's the Amory ice sheet. And sometimes we see it come up there. There it is. See the lighter color. Now we're starting to see these dark blue waves come in the southern hemisphere. That's a sign when methane starts going down in the southern hemisphere. It's and this dark blue is the dark blue is 1800. Okay, I said the dark green was 1800. I'm mistaken. I'm sorry. The dark green is 1920 parts per billion. So the dark blue is 1800. So as the methane goes lower down here, when that dark blue takes over, we won't be able to see the outline of the Antarctic because that's black and it's hard to see, but we'll still be able to see if methane is coming up. It'll show up even better. Now we'll go to the global view. And you see this white spot popping up in China. That's near Beijing, and that means it's higher than the 10,000 parts per billion. It's higher than what they can register on the chart. So it really puts things into perspective to be able to see, worldwide where everything is, what's going on. We see that China and India had the highest methane. And see that we've got a lot more dark blue creeping in, especially around the equator. So it's redistributing and going down somewhat. Now we'll look at 500 HPA. So we have the darker readings up here by Novaya Zemlya. You can see it really dark up there. And out to Franz Josef Land. Now this is Svalbard here. It's kind of a weird angle. This is Severnaya Zemlya, and so Komsomolets is right down there. We're starting to see a little bit of blue here over the Pacific, a little bit of blue in the Atlantic too. That's a sign of lower methane. It's not just solid green down here. Now we'll look at total column. So the highest is China and India, and then look at this red wave. See it's coming across the Pacific, and I mean it's really unusual to see total column readings this high with the red waves coming across, and it's unusual, and the orange, so it's going up overall. Now we also have an ozone hole that's opened up. I'll go ahead and show this. It actually opened up. It's right up here by Norway. See the aqua color? Now the scale is the solid yellow is 300 Dobson units. That's considered to be average or normal. I mean, thick enough to protect you. But then when you go to the left, that goes thinner. So even like the slight yellow green, that's 280. The chartreuse, that green, is 260 Dobson units. Then we've got a kind of a blue green here, that's 240. Then the aqua is 220 Dobson units, and then once you get into this kind of bluish purple, when you see that, there's a big thick black line around it, because that's considered in the danger zone when it gets below 220 Dobson units. So that's 200 to 220. That's why you see this thick black line all around the ozone hole in the Antarctic. So I'm going to show you. Let's see, we'll do the Arctic view. It actually opened up late yesterday. I wasn't aware of it. I take these pictures at the beginning, at the beginning of the day here, every day. And I'll just show you where it opened up. See here where it starts opening up, and this is the Norwegian Sea, just between Iceland and Norway. This is just north of the UK and Scotland there, and that was about the middle of the day that opened up. Okay, now, so it started yesterday, but look at it today. Let's go to today. Look at that. It's bigger. Now watch. And it's raining there too. And there's methane coming up, so and this area got quite a bit of sulfur dioxide. There was an arm that shot up from La Palma up along here, but so this area is not looking good at all. So there's that. Now, let's see, what do we want to look at next? Let's finish up my pictures here. Here's sulfur dioxide today. This is from La Palma, and it's been erupting for going on 5 weeks now. I think we're started into week 5, and it's not slowing down. Not sure what's going to happen there, but it's not looking good. And then Mount Etna has been erupting. That's why it's so dark there. This is leftover sulfur dioxide that has streamed out from La Palma. This is from pollution at China. This is from pollution at India. And these are from volcanic activity down here in the South Pacific. Here it is at 500 HPA. When you have volcanic and sometimes earthquake activity, it'll shoot up to this high level. This is about halfway up in the atmosphere, and it'll just shoot right up, and it'll register really high, like here at La Palma and here at Etna. And here we can see it's still quite dense over, that's Kazakhstan there. So it can hang around pretty thick, and even in the higher regions. Here's the ozone hole over the Antarctic today. Still big. I don't see that it's shrinking that much. The shape just morphs a little bit. We can see the thick black line all around these colors. It goes down 5 layers of thinness down to this black over the interior. That's the lowest reading, which is 100 to 125 Dobson units. If it goes below that, then we get a white spot. And we did have that for a few days, maybe last month, I think it was. I can't remember. And here's the Arctic. So here's the whole over Norway today. Here's the global view. And so this is just not good. When you got all these greens, the whole, from the US down to half of South America, almost all of Africa, and down to Australia, all in the green, that's quite thin. So that's just not good. Here's La Palma. These are pictures from volcano discovery today. A new vent opened up. And what happens, it keeps collapsing. It'll build up and then it keeps collapsing, and then new vents keep opening up and the lava is just streaming. Here it is today in the daytime. See where the lava is just spewing up? I mean, it's just shooting up. And then you've got the ash cloud too, and here it is coming down. And here the earthquake. This is also from volcano discovery. Well, it's from EMSC. And they talked about the grid pattern, and I'm going to show you that in a moment. Now, before we get into sea ice, let's go over La Palma. We'll have that done. Now, here's EMSC. This is, they track earthquakes here. This is La Palma, right down here, where you see all the red dots there. And 242 earthquakes when I did this a little earlier today. That was in the last 24 hours right there. A lot of them are in the 3s range. Let's see, 3s, high 2s. I saw a 4.1 in here. I saw a video that they had a 4.9. I didn't see that yet, but I didn't go back through all these pages. 242, that's a lot of pages. Now if we refresh, we'll see what it is now. So it's gone up 263 now. So the earthquakes are increasing. That's in the last 24 hours here. And I've been watching this area. There were some earthquakes here to the east of this little island, Tenerife, just east of La Palma. So it wasn't just here at La Palma. So that was kind of alarming. So here are the recent ones, high 2s and then 3s, and the depths are, here's 8 kilometer, 10, 14, Here's one 34 kilometers deep. These are quite a few threes. Anyway. And then you can click on these pages and it loads however many. In the page, I don't remember how many this is. But these are all at La Palma. See 3.4 and so on. So it's not slowing down. In fact, the earthquakes are picking up in number. And USGS has not reported one earthquake here. Not one. And the earthquake started the week before the volcano started going off. So the earthquake started 6 weeks ago, and then the volcano started 5 weeks ago, and it just keeps going. And I also use Zoom Earth. This is current time, and I've got the heat layer turned on, and we can see where the lava is. See, it's headed north. It says heat signature, but this is the lava. See, it's going north. Right now it doesn't look like there's any going into the ocean, and that's the first time I've seen that it stopped going into the ocean. But the bad news is, with the new vent, now the lava is going more north. We also, I didn't mean to do that. We also have some lava headed south over the old lava too. And then the earthquakes are all around here. Now, let's go to Volcano Discovery. This is the site that I use mostly for all the updates. And I post these, the long updates. I post these on my Subscribestar page as public posts every day that people can go to and see. I've been posting all of them. So let's see the post from today. Now these are where it says ash advisory. I don't post those. I normally don't look at those, but you can if you want to. It's all kind of in a code. You have to learn to read the shorthand for it. Look at that. These are advisories. That was yesterday. I did that in my show yesterday. Okay, here is the main update for today. Eruption intensifies, new lava flow to the south. Oh, it's flowing to the north too. Look at that. See, there's the town right down there. And it's covered up so many towns already. The intensity of the eruption increased. Since the last update, at least 4 active vents had been generating violent pulses of lava fountains, with ash columns rising to approximately 3 kilometers, as well feeding both surface lava flows directly from the vents, as well as fueling the hidden from view lava tubes that transport most of the lava to active areas of the flow field downslope. Volcanic tremor has increased significantly. Yes, I would say so. During the latest hours, likely heralding that a strong pulse of magma is reaching the vents. The southeastern vent that had been reactivated or opened a week ago and so far only showed explosive activity, now also started to erupt more lava and form of pulsating lava fountains. This vent now feeds a new lava flow, then travels towards the southern slopes and has already reached the San Nicolas region in Las Manchas. An impression of the activity at the volcano yesterday is seen in the following video. So we'll see what that does. How long is this? 48 seconds. Look at that. See the pulsing? Pulsing. And here's the main crater. This is Cumbre Vieja. And then see it's coming up here too. So that's on Twitter, it looks like. That would be scary. Okay, according to the latest data, 891.9 hectares of land have been covered by lava, and 2,270 buildings destroyed or damaged, and a lot of those are homes. Earthquakes continue to increase, if not in size but in numbers, remaining in the same area, mostly around 12-kilometer depth, beneath the center of the volcano, Cumbre Vieja. During the past 24 hours, the island had shaken by 77 quakes of magnitude 3 to 3.9 and 121 quakes between 2 and 3.0. Let's look at these pictures. See if that's going to load. I don't think that's going to load. Anyway. Then, let's go back up. Then this was the next update, and this was just a short one, and this was at nighttime. It says activity is intense this evening. You can follow it live on the Kind Media webcam, and there's a link to that. And then the next update was here, where they're talking about the earthquakes. Quakes at La Palma are not artificial. And there's see the grid pattern, and see here's some out in the ocean on either side. Okay, we're going to read this. Unfortunately, there are currently articles going around in the net. Example, HalTurnerRadioshow.com, and it leaves the link, that misinterpret plotted quake epicenter data for recent quakes at La Palma. One should understand that reported quake locations are necessarily rounded values, and if plotted on maps are arranged on a grid, reflecting simply the margin of error of measurements, normally the size of the last digit after the decimal If rounded to 2 digits in latitude and longitude, it is an approximate 1 kilometer resolution in this case. So, and I've seen that before. We've had, I've seen it even here in Nevada. We had some, and if you want to read more about that, there's a link. It says, why seeing quake epicenters sometimes distributed along some sort of grid. So this is kind of long. Okay, well, let's just read some of this. Sometimes when you zoom in a lot on maps showing earthquake epicenters, the locations are arranged on parallel north-south and east-west grid lines. This is an artifact caused when the calculated locations of quakes are rounded to the closest decimal after the comma, whose value is still larger than the error span of the measurement, and not to suggest a wrong level of accuracy that simply cannot be achieved. And then it goes on. So, anyway. So you can read this if you want. So they're saying this was not, these were not artificial earthquakes that they registered on the grid. And I would think, you know, when you've got 264, you can't put every single little dot. I mean, it's got to go, you've got to organize it a little bit. So there's that. Now, and then here's a satellite picture. See, it's cloudy today. Ongoing emissions. And that's it. Now, let's move on. Now, I wanted to show you something. This is National Snow and Ice Data Center. They're having technical difficulties preventing the processing of new data files at this time. We do not have an estimated time for resolution. We apologize for any inconvenience and thank you for your patience. No data on the daily. If you want monthly, you've got data on the monthly, but if you want daily data, there's no data for extent or concentration. But what was interesting is they do have this is the sea ice extent, and here I'm going to do this so I can blow it up. Arctic sea ice extent chart, and this is October 19th. That's Tuesday, and this blue line is this year, the dotted line is 2012, and it looks like, see where it was refreezing, it's sloping off. It looks like it went up a tiny bit there, but not as high of an angle as it had been. So much slower on a little refreeze there, and it's gonna probably has intersected with the 2012 line if we had that data. Now what was interesting, well, I don't have it pulled up, but when I did my midweek update, I downloaded the chart here, and it was different. The line was going straight up. So they've changed it, or they've updated it. They've updated it since then. So that's what it is right now. And same thing on the Antarctic. Let's see. Daily, no data. And they've got their chart here. Let me blow it up. And see, for October the 19th, the blue line is this year, the green line is last year. The light gray line is the average. And so, see, it's melting down there because they're heading into summer. As we're heading into winter in the northern hemisphere, they're heading into summer. The sun is up and the ice is melting, but it's showing that it's a little bit bigger in the last few days there, last couple of days there. I'm wondering if it could just be the ice spreading out as it's melting. They counted it as extent. It's still a lot lower than this time last year, and it's lower than the average. So there's that. Now, I want to go over Climate Reanalyzer next, and then we'll go into sea ice. We'll spend the rest of the time on sea ice. Here's 2 meter temperature anomaly for today. See all the red here just above the Canadian archipelago. And so this is warmer than normal. That bright red is about 18 to 20, maybe, 20 parts per billion, or 22, I don't know what the division is there. 18 to 20 C higher than normal. So that's right over what's some of that thicker ice. It's goes up like that. We've got browns over the Beaufort Sea, browns over Alaska, Canada. Greenland is in the blue. We've got browns over the Laptev Sea, browns over a lot of Russia, but we've got a lot of blues too. Here's all this blue with the colder air. Here's the flat view. Worldwide, we're up 0.5 C higher than normal. The northern hemisphere is up 1 C. The Arctic is up 2 C higher than normal. Tropics are up 0.3 C. Southern hemisphere is down 0.1 C. And the Antarctic is down 0.5 C, lower than normal. Here's precipitation and clouds. We can see that Norway is getting hit with a big swath of rain there. We've also got rain here in Russia. Wherever there's permafrost, you know that rain will thaw out that permafrost. We've got rain coming up to Iceland. See, we've got rain also here in Canada, and this big atmospheric river is coming across the Atlantic now. We also have a system, it looks like, just coming on to Mexico. I haven't been following any of that. The big news is all this coming in on the west coast of the U.S. here. That's what I've been following. Let's see, jet stream, no stream, see the loops and the breaks in the stream. It broke earlier this year and it's still broken. We have, here's a low, but that's where it's hotter than normal. But we've got a low pressure system there right over the Beaufort Sea. We've got a low over the Laptev Sea. We've got a high pressure system next to the North Pole. We've got a low pressure system here in the Barents Sea. And see, it's just crazy. It's all over the place. There's the flat view. And southern hemisphere is all broken up too. There's no rhyme or reason. We have weather chaos. Here's sea ice and snow cover. I'm going to show this more in detail. Here's sea surface temperature anomaly as of yesterday. We're still seeing a lot of browns and into the red, almost red here on the Russia coastline, in the Barents Sea and the Kara Sea, and here around Svalbard. We've got a little bit of brown here in the Laptev Sea. That's warmer than normal. We've got a lot of red and into the pink zone and browns here in the Hudson Bay. And then all around Greenland it's in the browns, and we've got reds. See the reds here in the Great Lakes and reds on the east coast of US and Canada. We also have this red blob out here in the middle of the Pacific in the northern hemisphere, where it's so much warmer than normal. Also, look at Australia and all the browns around Papua New Guinea and Australia. So it's heating up down here. And here, between Australia and New Zealand, this Tasman Sea, we have to watch that. Sometimes it gets really hot. It's an area that just tends to really heat up during their summertime. Also down here in the South Pacific, in the summer down here, we'll have a lot of times a hot spot show up and kind of hang around down there. So we'll be watching all that too. Worldwide, we're up 0.4 C higher than normal. The northern hemisphere is up 0.6 C. The North Atlantic is up 0.9 C. The North Pacific is up 0.5 C. Southern hemisphere is up 0.2 C. And the equatorial Pacific is down 0.1 C. So there's that. Now, we saw that. Okay, I'm going to close that. I'm going to close that. Let's see. Okay, now we'll go back to our slideshow here. Here are the pictures that I've downloaded from Climate Reanalyzer for this week on sea ice and snow cover. Here we are today. And we can see it's come back around Franz Josef Land. This is just really thin, just very thin ice. Also see it's around Severnae Zemlya, coming down along the Taimyr Peninsula here by the Kara Sea. Here we've got spotty refreeze happening in the Laptev Sea and all around the coastline. Here in this East Siberia Sea, that's filled in. All of this is thin, but it's filled in. And the edge has come back out here in the Chukchi Sea, and here in the Beaufort Sea. It's trying to come back up to the Alaska and Canada coastlines, but it's difficult with the ice drift that's going on, and also the warmer air that we saw over this whole archipelago region. And we've got a little bit of regrowth here in these tributaries, and also along this east side of Greenland. But Svalbard is still clear because the water is just too warm around here for a refreeze. The Barents Sea and Kara Sea, for the most part, are open because the water is too warm, as we saw. Also, not much refreeze in the Baffin Bay yet because the water is too warm. No refreeze here in the Hudson Bay yet. We saw this is brown, red, pink as far as sea surface temperature. Also here in the Great Lakes, same thing. Just take some time. Okay, we'll go through what happened this week. Here we were on our show last Sunday. We had the Laptev Sea was open, so we'll see what happened here this week. Here's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and here's today. So it's filling in, and we're see the whites. That's the snow on land, and so we expect to see that too. Then these are models from the U.S. Navy. This is sea ice thickness in the Arctic for today. There's the chart on the right. The dark purple is about 1 meter thick. The light lavender is where you see it go from white, that's 0, and then like the little wispy lavender, and then the light lavender is about 1/2 meter thick, down to the dark purple is 1 meter thick. The dark blue, like this color here that's coming in, is about 1.25 meters thick. The dark aqua is about 1.5 meters thick. The bright aqua is about 2 meters thick. Then, once you get up into the greens and yellows and reds, it gets thicker. We're not seeing much of that, if any. It's mainly, see the purple and light purple, and then we've got the dark blue coming in, just a little bit around this basin, and then the bright aqua, see, around this Greenland coastline, a little bit down here on this archipelago, but this is more dark aqua here. Now, one thing that's kind of got my attention is this Lincoln Sea, and when we run the 30-day animation, you see this area get bigger, or I mean, not have as much aqua. It's more of the light purple, showing that this ice is pulling away or melting or something, but it's not really doing the refreeze like I think they should, or it should. So if anyone has any ideas about that, leave it in the comments below. So here's our refreeze on the east side. We have a little skim of ice coming down to this top part of Svalbard. Here's Franz Josef Land, and then here's Severnaia Zemlya, and so right down here at Komsomolets, right around this area, is where we see the methane billowing up so profusely for the last almost 2 years. Here's a little bit of refreeze in the North Kara Sea. So this corresponds with what we're seeing. You'll see it corresponds with NASA Worldview, and also corresponds with Climate Reanalyzer. We've got a little bit of open water left here in the Laptev Sea, so it's coming back very thin, and here in the Beaufort Sea, it's thickening slightly. A little bit of wisp coming up to the coastline, and then north of Greenland we've got a little bit of thicker ice on the coastline. There's an area just north of that is staying thin. I don't know why that is, but we're not seeing the aqua come in yet there. We have a little bit of aqua just above that, and then this area, which looks like a weird exclamation point with some holes in it, is what's left of the thicker sea ice from this year, and it's just hanging out. It's not really doing much. I don't see it thickening. I don't see it really changing. Now, with the ice drift, this has pulled out. See, it's not anchored. And you'll see in the animation where it pulls out and it's starting to slide down towards the Beaufort Sea, just like it did last year. Here's the 30-day animation. The data goes back 3 weeks, and the forecast goes out a week from now. So let's see what's happening. So we're seeing that, the refreeze come back thin. We're not seeing, I would like to see this thickening up faster than it is. I just am not seeing that. Now watch this Lincoln Sea. Look at that. See, it starts out with more aqua, and see, it opens up into the thinner ice. I don't know what's going on there, but the ice is going away. And see, it pulls out. Watch. There it goes. And then it starts sliding. This is, well, if I look real close, this is starting to thicken up a tiny bit. So that's what we've got. Here's the Beaufort sea ice thickness for today. Alaska's down here, Canada is over here, and see the little wispies coming down to Alaska, and here it's coming down a tiny bit in this Chukchi Sea. So here we have some aqua ice and a little bit of green and a little hint of yellow, and see how it's pulled away. We've got white, meaning no ice along this coastline, these coastlines. So the ice drift pulled this thicker ice away, and we've got some purple ice here. Now watch. Here's the 30-day animation. Watch it. See, it pulls out and then slides. And see, this Beaufort Sea is not really thickening that much. And these little aqua nubs, that's left over from the multi-year thicker ice last year that drifted down during the winter last year. That's what's left of it. That's what we've got. Here's the Antarctic sea ice thickness for today. So we've got the thicker ice, and most of it here in the Weddell Sea, and the ice shelf is down here. We've got some thicker ice around this western edge, but look, right around the coastline, here's Pine Island Glacier, and down next to Thwaites. See, there's so much open water, and here in the Ross Sea, right next to the ice shelf, see, it's open water. More open water down here on this southeast edge, open water here on this eastern side, and see this, the ice has shrunk in, that it's really melting down there. So all of this is in the sunlight now, and see, it's quite thin up here in the Weddell Sea. So here's the Western Peninsula. So let's look at this 30-day animation. You can really see this edge shrinking on this east side. See, that's going way down. Now, most of the ice does melt in their summertime, and then in the wintertime it refreezes around the continent. So it's just different, a whole different scenario with the landmass in the center rather than in the Arctic, where you have the water in the center and the land around it. So there's that. That's all of those. Now we'll take a peek at NASA Worldview. So here's the Arctic, here's Greenland, here's Canada, Alaska, and then Russia over here. Here's Norway down here. This big black circle, that's where it's dark up there with the sun going down. So I like to turn on the sea ice concentration layer, and these colors show us at what level of concentration it is. So where it's refreezing, you'll see different colors. Or if it's melting, you'll see different colors. But generally, it's refreezing right now. Here's Svalbard. Here's Greenland. Let's turn off or turn on this blue marble layer. It's a little easier to see things. Here's where it's refreezing in the Kara Sea. Here's the Yalma Peninsula. We're starting to see some little dots of ice here. Now here's Severnaya Zemlya. And this is open water here. Open water, open water. Here's the New Siberian Islands. This is the Laptev Sea. This is the East Siberian Sea. See where the ice is filled in. It's really thin though. See, it's white, showing it's concentrated because it's all like one little thin layer of ice on it. It's not like pieces of ice with space in between. And then here in the Beaufort Sea. So we've got some holes here. See? And then here's where it's pulled away from the coastline. And here by Greenland where it's coming down. So we'll go back to last week. Here's where we were last week. See, this big area was open in the Laptev Sea last week. So let's see what's happened. So what happened from, watch here, yesterday here in the Beaufort Sea, and look, it looks like it's melting there. It could be that warm air. I don't know. But remember, the water is warm underneath. It can melt from underneath. Just because we've got a little bit of thin layer doesn't mean that we're out of the woods. So there's that. Now, let's see what we can see. The satellite. Kind of hard when you're looking through clouds. Here's some ice. See? That's what it looks like. See, there's the ice. Here's ice. See, there's still a lot of open water between a lot of those pieces there. Just takes time, and you know, it's got to cool down. See, these leads have not refrozen yet. So there's that. Now let's go down to the Antarctic. So here's the Western Peninsula. This is the Ross Ice Shelf. Here's the Ross Sea. We'll start down here. Here's the Ross Island. It's kind of hard to see. It's kind of cloudy. Let's go back. Here's yesterday. That's better. See, this is Mount Erebus. That's a volcano. Right up here on this little tippy point is the McMurdo Station, research station. And see, this ice is breaking up. See, it's already pulled away, melting. See, a lot of open water there. This is the ice shelf that comes out. This whole area is the Ross Ice Shelf. Then the Ross Sea is here. So that's going to be melting fast, see? Let's move around. Look at that open water. Let's go back to today. Look at this. That's melting fast. Look at that. A lot of open water. Some of this never refroze during their winter time. Or a lot of it never refroze even. Now, Let's find. This is the Thwaites Glacier. It's under a big cloud right there. Look at all this open water. Let's see. This is the Pine Island Glacier. We've got a cloud over that. This is the Thwaites. Let's go back. Now you can see the crack. This is where the tongue came down. It broke off and then it refroze, but then look at this big crack along here already. Now that was on the 18th. Let's see if we can see anything. It's just too cloudy. Let's see. Uh-oh. Wrong day. Nothing there yet. Okay. A lot of open water there. And then here's the Western Peninsula. This is see. A lot of clouds. Here's the ice. Here's the edge. See? There's the edge. See the wispies? Look at that. This is the Weddell Sea. This is the Weddell ice shelf here. Right down here, this is the Brunt ice shelf, and this is the edge that goes on up. This is the area that we see methane coming up on CAMS. Look at all this open water. See? I'm thinking underwater volcanoes are keeping this kind of warm. And this, here's the big iceberg that broke off at the beginning of their winter. It broke off up here and it migrated down here. It's right down here now. Here's the northern end. Here's the east side. This is the Amory ice sheet. This is another area that we see methane come up. And see the open water. See, this is just very thin ice here, but it's open right up to the shelf there. But see, that's melting fast. See that? And here's the ice sheet. And there are several glaciers that empty out into this ice sheet. Let's see. This is the Totten Glacier. Here, the tongue comes down. Look at, that's melting fast. Look at, just from yesterday, that broke off. Look at that, in one day. That's shocking. So, we're going to see high melt here this year. I think it's going to be really astounding to watch the ice melt this year. I think we're going to start seeing stuff on the land that we weren't able to see before, because the snow was going to melt too. And we're back to where we started. There's the South Pole right there. That's my report for tonight. And I like to bring things back to a spiritual perspective, since we are in the end times, and all of these things were prophesied by Jesus. He told us what to expect as things get closer and closer to the end, and earthquakes and lots of changes in climate and land, and it's just the whole thing. Wars, plagues, famines, the whole thing. We're right there, getting closer every day. And tonight we're reading out of Matthew. Matthew was one of Jesus's disciples, and this is the life of Jesus, and the words in red are the words from Jesus. Matthew chapter 17. And after 6 days Jesus taketh Peter, James, and John his brother, and bringeth them up into an high mountain apart, and was transfigured before them. And his face did shine as the sun, and his raiment was white as the light. And behold, there appeared unto them Moses and Elias, talking with him. Then answered Peter, and said unto Jesus, Lord, it is good for us to be here. If thou wilt, let us make here 3 tabernacles, one for thee, and one for Moses, and one for Elias. While he yet spake, behold, a bright cloud overshadowed them, and behold, a voice out of the cloud which said, This is my beloved Son, in whom I am well pleased, hear ye him. And when the disciples heard it, they fell on their face, and were sore afraid. And Jesus came and touched them, and said, Arise, and be not afraid. And when they had lifted up their eyes, they saw no man, save Jesus only. And as they came down from the mountain, Jesus charged them, saying, Tell the vision to no man, until the Son of Man be risen again from the dead. And his disciples asked him, saying, Why then say the scribes that Elias must first come? And Jesus answered and said unto them, Elias truly shall first come, and restore all things. But I say unto you, that Elias is come already, and they knew him not, but have done unto him whatsoever they listed. Likewise shall also the Son of Man suffer of them. Then the disciples understood that he spake unto them of John the Baptist. And when they were come to the multitude, there came to him a certain man, kneeling down to him, and saying, Lord, have mercy on my son, for he is a lunatic, and sore vexed. For ofttimes he falleth into the fire, and oft into the water. And I brought him to thy disciples, and they could not cure him. Then Jesus answered and said, O faithless and perverse generation, how long shall I be with you? How long shall I suffer you? Bring him hither to me. And Jesus rebuked the devil, and he departed out of him, and the child was cured from that very hour. Then came the disciples to Jesus apart, and said, Why could not we cast him out? And Jesus said unto them, Because of your unbelief, for verily I say unto you, if ye have faith as a grain of mustard seed, ye shall say unto this mountain, Remove hence to yonder place, and it shall remove, and nothing shall be impossible unto you. Howbeit this kind goeth not out but by prayer and fasting. And while they abode in Galilee, Jesus said unto them, The Son of Man shall be betrayed into the hands of men, and they shall kill him, and the third day he shall be raised again. And they were exceeding sorry. And when they were come to Capernaum, they that received tribute money came to Peter, and said, Doth not your master pay tribute? He saith, Yes. And when he was come into the house, Jesus prevented him, saying, What thinkest thou, Simon? Of whom do the kings of the earth take custom or tribute? Of their own children, or of strangers? Peter saith unto him, Of strangers. Jesus saith unto him, Then are the children free. Notwithstanding, lest we should offend them, go thou to the sea, and cast an hook, and take up the fish that first cometh up. And when thou hast opened his mouth, thou shalt find a piece of money. Take that, and give unto them for me and thee. Matthew chapter 17. So, if we will draw close to Jesus, he will protect us and guide us in these end times, in these end days. And that's the only protection we're going to have from God and Jesus. And the Holy Spirit will help us to not be deceived, will help us to see the truth, to discern the truth. And it's very important. So I'm praying for all of you. I hope you have a good week. And until next time, God bless you. Go in peace, and I will talk to you soon. Good night.